Now we're going to look at writing higher order ordinary differential equations as a system of first order differential equations. We want to do this because often numerical solvers and numerical ways to solve ordinary differential equations are based on first order differential equations, whether they be single ODEs or systems, they're all first order. And so to use those solvers, in order to use them, we have to write the higher order differential equations as a system of first order differential equations. So, for example, suppose we have some ODE that, let's say we have some y to the n, some nth derivative is some function of, say, t, y, y prime, y double prime, all the way up to n minus 1, like this. In other words, we have a higher order differential equation that we can write as a function of t, of y, and all the derivatives of y up to n minus 1. And we'll look at an example and it'll be clear how this works. But first of all, to solve this, let's first define y1 equal to y, y2 equal to y prime, y3, and then y3 is y double prime, and so on all the way, so that yn is equal to y, the nth minus 1 derivative, like this. So in other words, so we define these this way. Then the next thing we're going to do is take the derivatives of each of these. In other words, we're going to take the derivative of, like, this one of both sides. So again, we're going to take the derivative of both sides of this, y prime, like this. Then take the derivative of both sides of this. And now if we do the left side, that'll make it y prime. The right side will be y double prime. Then take the derivative of both sides of this, y3 prime, y triple prime, and then go on as many derivatives you have. And then the very last one, of course, will be y, all the way down to y n prime is equal to y, another derivative here, which is going to be y to the n. And then now reassign these values. So we want to reassign these so we don't have any derivatives on the right. So let's reassign. In other words, what I'm saying here, y prime, you can see over here, is equal to y2. So on the right-hand side, we can write that as y2. And then over here, y double prime is equal to y3 on the right-hand side. In other words, I'm replacing all these right-hand sides. So here, y double prime is going to be replaced by y3. And then the next one, y triple prime, I didn't write it here, but that's going to end up being replaced by what, y4. and then all the way down. And then the last one over here, y to the n, will simply be the original equation. So when we get to the very last one, y prime n, then this right-hand side is just going to be our original equation up here. Again, we'll see an example of this, and then it'll be pretty clear. So let's take a look at this example. We're given this higher order differential equation. It has a third derivative in it and the second derivative. And it has these initial conditions. And we want to write this as a system of first order equations. So let's take a look at that. Again, it's exactly what we had, what we started a minute ago. We have like the right-hand side is a function of lower derivatives. The left has the highest derivative, so it has the form that we need. And then, so let's go ahead and do that. So we said before, we want to define all the derivatives we have here. So we want to call, and we also have to define y. So here we have y1 is going to be equal to y. y2 is going to be equal to the first derivative. y3 is going to be equal to the second derivative. And now that's as far as we go, because remember, we stop one short of the highest derivative. In other words, here we have the third derivative, so we stop one short of that. And then we start with y. So basically what we have is from y up to the highest derivatives on the right, or you can think of it as one short of what we have on the left. So take the derivatives. And again, take the derivative of both sides of this equation. Both sides of this equation. Both sides of this equation. And so again, that's kind of what we were doing in our theory part. And then reassign these. And I really should say reassign the right-hand sides of each of these. I'll say it like this, reassign the right-hand side. So in other words, for each of these, we want to replace this with something over here. So in other words, y prime here can be replaced by y2. And then the next one, y double prime here, can be replaced by y3. Excuse me, by y3. And then, as I said before, when you get to the highest derivative, replace that with the original equation. And the original equation up here is 2y prime plus log y double prime plus cos y. Now, the only thing is, though, we want to replace this then so that we don't have, so we have like y's with a subscript. So let's go back and see what some of these are. So y prime here is going back here is going to be y2. This, so we want to be sure not to have any derivatives on the right hand side. So y prime is replaced by y2. Y double prime is replaced by y3. Y sub 3. And then finally, we want to have a subscript on y, and that's up here replaced by y1. Like that. So that's something to remember when you get to this last step here. Again, on the right-hand side, everything should have a subscript with no derivatives. So y prime played by y2, y double prime by y3, and y was replaced by 1. So now let's actually summarize this and write it out real nicely and see what we have. And so if we write it real neatly, here's our system of equations here. But then one thing we want to do, what about the initial conditions? So we want to rewrite those as well, because it's not going to do us any good to have our system in this form and have our initial conditions as they were originally. So once again, if you look back at your original problem, again, replace everything so that it has a subscript and no derivatives. We want a subscript and no derivatives. So here we have y. And so if we look down here, we want to replace that with y1. So it'll be y1 of 0 equals 1. And then for the next one, we have y prime. Again, we want to replace it with something with a subscript but no derivative. Y prime is y2. So we're going to have y2 of 0 is minus 3. And then finally, for our last one, we have y double prime. We want to replace that with something with a subscript with no derivative. And go down here. Y3 is y double prime. And that's 5. So again, if you follow this method, this will work for any ordinary differential equation of higher order. The only thing is you have to solve it so that you have the highest order on the left with nothing multiplied. Solve it like this. And then go through the steps we have here. Define up to the highest derivative minus 1, define y1, y2, y3. If this was over here, if this was y to the 6th derivative on the left, we would go all the way up to 6 here. Y6 would be equal to the derivative of y to the 5th. Do that, take the derivatives, reassign the right-hand side, and then be sure that in the end you only have y's with subscripts and no derivatives. Reassign the initial conditions, and you're set. Now, there'll be another video to transform a system of higher order differential equations into a system of first order differential equations. That's a separate video.